Two spherical conductors B and C having equal radii and carrying equal charges on them repel each other with a force F when kept apart at some distance. Two spherical conductors, this is A, this is B, right? They are kept at some distance. Let us suppose x is the distance. Both of them are carrying the same charge, Q and Q. The radii is same, right? So that means the force between them will be what? K Q square upon x square, right? So this will be the force F. Now since the C, this conductor C is brought in contact, a third spherical conductor having the same radii as that of B, right, but uncharged, is brought in contact with B. If this is uncharged and they are brought in contact, what happens when B and C are brought in contact? If this is having a charge Q, this is having zero charge, what happens? Some charge Q gets transferred from here to there, right? So that means C conductor develops a charge plus Q and the charge on this remains Q minus Q. Now this charge is redistributed in such a manner that both of them are at the same potential, right? Now since what is the potential of B? K into Q minus Q by R, and this should be the potential of C. So what will be that? K into Q by R. Now since they have the same radii, that means charges on them should become the same. That means Q minus Q should be equal to Q for the potential to be same. It implies that Q will be equal to Q by 2, right? So that means afterwards this charge will become Q by 2 and on C it will become Q by 2, right? So this we have calculated. Now what happens, let us see. Then it is brought in contact with C and finally removed away from both. Right. So this C is again brought in contact with A. This is brought in contact with A and it is finally removed. So what is happening basically? Now this is A and this is C, right? Now what will happen? If this is having a charge Q, this is having Q by 2, what will happen? Some charge, let us suppose Q dash, goes from here to here. So that means again the potential should be same. Again they are having the same radius. That means the total charge left should be same. That means Q minus Q dash should be equal to Q by 2 plus Q dash, right? So that means it implies that Q by 4 is equals to what? Q dash, right? So that means afterwards on A, what is the charge? Q minus Q dash, that means 3Q by 4, and same is the charge on this thing, 3Q by 4. So now this A is having a charge 3Q by 4 and B is having a charge Q by 2. So what is the force? F dash, if I talk about, this will be K into 3Q by 4 into Q by 2 upon x square. The distance is same. So let us mark it as 3 by 4 into 1 by 2, right? Now this part is what? This is initial F. So that means 3F by 8, right? So this is the correct answer. That means D option is correct.